In Google search, you type Quirk quantum simulator. So Quirk quantum circuit simulator will come. Select this one. This page will appear. So now we can edit the circuit. Here we can see the tools. The first one is control, and this one Pauli X gate, Y gate, Pauli Z gate, swap gate, and Hadamard gate. These are the states. We can change the states 0, 1. And here, if the output is 1, this green color light will come and block sphere will show the value 1. If the block sphere towards the up means it indicates the 0, down means 1. And this is amplitude display. In this amplitude display, if the pointer is towards the right side, it indicates the plus value. If the pointer indicates towards the left side, then the value will be negative. If the pointer is towards the up, then the value is with plus I. If the pointer is towards the down means the value, that is the output, will come with minus I. So first we will take Pauli X gate. When the Pauli X gate acting on the ket 0, the output will be 1. Block sphere also shows the value 1. 1 means the pointer is towards the down. And here in the amplitude display, first you have to check horizontally and then vertically. Okay, so under horizontally my output is 1, so near the 1 only it will show the amplitude value. Here you can see the circle and the pointer is towards the right side, so value is plus value. Now Pauli X gate acting on the state 1, the output will be 0. 0 means in the block sphere the indicator will show towards the up. The value is 0, so if you check the amplitude display horizontally, here this is the 0, so near the 0 only you can see the circle and it shows the positive value. Now I take Pauli's Y gate. Pauli Y gate acting on ket 0, so the value will be 1. Block sphere also shows the value 1, that is the pointer is towards the down. And here in the amplitude display you can see the pointer is towards up. Up means the output is with plus I. So plus I ket 1 is the answer. Now Pauli's Y gate acting on the ket 1. The result will be, that is the output will be 0. 0 means year off. Okay, and the value is with minus I. So minus I, that is why the pointer is towards the down. Next, Pauli's Z gate. Pauli's Z gate acting on the ket 0. The result will be 0. Okay, in the amplitude display also shows the value 0. Block sphere also shows the value 0. Now Pauli's Z gate acting on the ket 1. The value will be 1. So for 1 it shows, block sphere also shows the value 1, that is towards the down. But you can check the amplitude display. Here the indicator is towards the left side. So left side means our output is minus 1. So when the Z gate acting on the ket 1, the output will be minus 1. So next I am going to take swap gate. So this is the circuit symbol of the swap gate. For swap gate you have to use 2 qubits, that is 2 states 0 0 0 1 1 0 1 1. The swap gate will swap the qubits value. First qubit value will go to the second qubit place. Second qubit value will come to the first qubit place. So first I have taken 0 0. The output will be 0 0. Block's pair also shows the value 0 0. Now you check the amplitude display. Here first you have to check horizontally. So where here only 0 is there, and vertically here 0 is there. This 0 and 0 will meet in this square only. So in this circle you will get the output. It is in positive value. Next, get 0 and 1. As I already told you this, it will swap the values. The 0 will go to the second qubit value and this get 1 will go to the first qubit value. So when you give 0 1, it will give the value 1 and 0. You can check the Bloch's pair. It also shows the value 1 and 0. And here in the amplitude display, first you check horizontally. Here 1 is there. Vertically here 0 is there. So this 1 and 0 will meet here. So you will get the pointer towards the right side because the value is plus. Next, I am choosing the state 1 and 0. So when you give 1 and 0, the output will be 0 and 1. It will swap the values. So for 0, Bloch's pair will show towards the up. For 1, Bloch's pair shows the result towards the down. Okay, so output will be 0 1. So here 0 and here 1. These 0 and 1 will meet here. And the value is in positive. Next to 1 1. You will get the 1 1 only because first qubit value will go to the second place. Second qubit value will come to the first place. So same 1 1 will get it. Bloch's pair also shows the value 1 1. In the amplitude display you can check here 1 is there, here 1. So here you will get the circle. Next we will do C0 gate. For C0 gate we need control and the target. So control will be acting as a first qubit, target will be acting as a second qubit. I am going to give different states. First I am going to give 0 0. If the control is 0, no changes will take place in the target. So if the control is 0 means no changes will take place. Same 0 0 you will get. And Bloch's pair also shows 0 0. Here you can see in the amplitude display 0 0 will meet here plus value. Next to 0 1. If the control is 0, even though if the target is 1, the value will not be changed. Same you will get 0 1 as output. So 0 1 here. Bloch's pair also shows the value 0 and 1. Here you can check the amplitude display 0 and 1. Here it shows the circle. Next I am going to keep 1 and 0. So if the control is 1 means it will change the target value. If the 0 means it will change to 1. 1 means it will change to 0. So 1 is the control. It's acting on the 0. It will change the output to 1. Control value will not be varied. So same 1 1 you will get it. Bloch's pair also shows the value 1 and 1 towards the down. And here you can check the amplitude display 1 and 1. So here you will get the value. Next to 1 1. Now control is 1, so it can change the target value 1 to 0. For 0, here it will show the off. Bloch's pair also shows the pointer towards the up. So 1 0 1 0. Here 1 and 0. So here you will get the circle. So now C0 gate is over. Swap also over. Next combination of single qubit and the multi qubit. So first I will take Pauli's X gate. Now Pauli's X gate, this is single qubit. Next I am taking control gate, C0 gate. C0 is the 2 qubit gate. So this is combination of the single qubit gate and the 2 qubit gate. Now when the Pauli's X gate acting on the ket 0, the output will be 1. Now this 1 only acting as a control. So when the 1 acting on the target 0, it will change the 0 to 1. So you will get 1 and 1. Block's pair also shows 1, 1, 1. So here you can check the amplitude display. Near 1, 1, 1 you will get the output. Next to 0, 1. So here control is 0. So no changes will take place. Same 0, 1 you will get it. And amplitude display also you can check. 1, 0. So 1, near 1 and 0 it shows the circle. Next to 1, 0. 1, 0. So when the X gate acting on the 1, the output will be 0. So control is 0. When the control is 0 means no changes will take place here. So same 0, 0 you will get it. Block's pair also shows the 0, 0. In the amplitude display you can check 0, 0. Near 0, 0 it shows the value. Okay. So next similarly we can do with Y and C0 gate, Z with the C0 gate. Now I am going to do a Pauli's X gate, that is single qubit gate with the swap gate. This is 2 qubit gate. Okay. So I am changing the state. First I am keeping at 0, 0. When Pauli's X gate acting on the ket 0, the output will be 1. Okay. So here 1, 0. 1, 0. So when you apply this swap gate, it will swap the values. So you will get the 0, 1. So for 0 it's showing off, for 1 it's showing the on. Respectively, Block's pair also shows the values and the amplitude display. So 0, 1, 0, 1, here you will get the values. Now you can change the state and you can note down the outputs. Next I am going to show the Hadamard gate. So Hadamard gate is used to produce the superposition state. Okay, so when the X gate, that is when the Hadamard gate acting on the 0, you will get 1 by square root of ket 0 plus ket 1. Okay, so ket 0 and the ket 1. Both are positive values. So here the pointer is towards the right side in the amplitude display. And it's used to produce the superposition state in ket 0 and ket 1. So in Block's pair also it shows the superposition state. Next, when Hadamard gate acting on the ket 1, the output will be 1 by square root of ket 0 minus ket 1. So for minus ket 1, here the pointer is towards the left side. Similarly, we can combine single qubit and the multi-qubit gates. We can play with the circuit. Thank you.